Hi students, so today we're going to go over simplifying radicals. So I'm using the simplifying radicals notes. Make sure you have that open in order to follow along and fill it out on the sheet. Make sure you use Kami to fill it out directly. So you should open it in Kami so that you can type directly on the sheet. Okay, so I'm going to read these notes to you really quickly, just so we have a general understanding of what's happening here. Some of these notes are going to seem, they're going to be using crazy words that you may have heard before, but you don't really remember. So just take it one step at a time as we think about what these words might mean and how we go about using them, okay? So don't worry too much about the meaning of the word as much as just thinking about whether or not you understand what I am doing when I'm doing these steps in order to show you how to get the answers that you're looking for in this assignment, okay? So let's see here what we can do with simplifying radicals. So step one, it says is to find all the prime factors of the radicand, or to do a factor tree. So basically what that looks like is to break down your number into all the numbers that make it up. And we got to go to the prime factor. So example of a factor tree would look kind of like this. So if I have the number 8, we'll start with a really simple number like 8. So what two numbers can I use to multiply together to get 8? Well, I can do 4 and 2. Okay, so 2 is a prime number, right? It cannot be broken down any smaller than 2. It's just going to be broken out into 2 and 1, right? So this is a prime number, so I can stop right there with 2. But then the 4 needs to be broken down again, and it can be broken down into 2 and 2. Right, because 2 times 2 is 4. So now I have all the prime numbers, for instance, of the number 8. This is what a factor tree would look like. All right, and we can do that, but when we're working with bigger numbers, it's going to be harder. So I'm going to show you a different strategy. But this is one way in order for you to be able to break down your number that is under the radical. Okay. All right, so what we can do to simplify it is to start like in this idea, right? But we wouldn't be doing the square root of 8 because 8 is a number that we know we can't break down. We already know that the square root of 8 is not something that we can find. So let's work with a bigger number. Let's try something, excuse me. Let me finish what I was showing you here with this breakdown. Let me undo this. Okay. So if I have the square root of 8 and I've already broken it down into this, right, 2 and 4, right, what that tells me is that the 4 can be broken down, but the 2 cannot. So I can actually rewrite something that if I have something like the square root of 8, because I know how 8 breaks down into 4 and 2, I can split that into the square root of 4 and the square root of 2, right? Because I know how my factor tree works. So what is the square root of 4? I can solve that. The square root of 4 is 2, so I'm left with just 2 times the square root of 2. This is how I can simplify the radical of 8, okay? Using my factor tree, I can simplify the radical of 8, right? So this is what you can do when we're doing it with big numbers. It's going to be very hard, but this is how you would break it down following these steps. This is step 1. Step 2 is to circle all the prime factors, which I did, right? And then take out the ones that I can break down. So I can break down my 4, and that's how I'm going to do it, right? And the reason that this works is because of the product property of square roots, right? This is going to be the same answer because the square root of 4 times the square root of 2 is the same as the square root of 8, right? Okay, so what we're going to focus on today is learning how to do it, not this longer way, but the shortcut way. But in order to know the shortcut way, I have to use perfect squares. So what I need to do is keep a list of perfect squares written down. And my perfect squares are the numbers that are products of factors that are the same number. So 1 times 1 gives me 1, right? So that means that 1 is a perfect square because 1 times 1 is 1. What's 2 times 2? 2 times 2 is 4. So 4 is another example of a perfect square. So any number times itself, whatever that product is a perfect square. So 1, 4, 9, 16, 25, 36, 49, right? 64, 81, and 100 are a list of the first 10 perfect squares, right? So if we know that any of these numbers, right, divides evenly into any of the numbers that we're simplifying, that's going to be the best way for us to simplify what's under the radical, is to use our perfect squares. So what I would like you guys to do right now, what's going to make it easier for you, is if you write down these lists of perfect squares somewhere on a separate sheet of paper, maybe just so you have it handy off to the side so you can look at them and know what your perfect squares look like. All right, because we're going to use all of those perfect squares to simplify these examples here below. We're going to use this shortcut. We're going to find the largest perfect square, and then we're going to do the last couple steps of simplifying by using that perfect square. And I'm going to show you an example of how to do that right now. Okay, so this first example is 162. So 162 is not a number that we hear very often, right? We don't really know what the factors of 162 are, but we know there are a lot of them because it's an even number and it's a pretty big even number, right? So I'm not going to do the factor tree method. That's going to take me way too long, all right? But I happen to know that 162 is evenly divisible by the number 9, and 9 is one of my perfect squares. So I'm going to use 9 as one of the numbers. And to figure out what number is paired with 9 that goes evenly into 162, I'm just going to divide 9 into 162. How many times does 9 go into 162? Well, it goes in at least once. It's going to give me a remainder of 72 and 18. So I'm going to use 9 as my first breakdown. So I'm going to break 162 into the square root of 9 times the square root of 18. Okay, the square root of 9 is 3. So I've broken that down completely. The square root of 18 is not an even number, but I can break 18 down. What are the factors of 18? The factors of 18 I could do a whole factor tree for 18, or I can think about, is there a perfect square that goes evenly into 18? Well, there is, 9. So I'm going to use 9 again. So I have the square root of 9 times the square root of 2. Again, what's the square root of 9? It is 3. Okay, so I have 3 times 3 times the square root of 2. So I have 3 times 3 times the square root of 2 for my answer. Let's simplify that even more by multiplying 3 times 3. What's 3 times 3? It is 9. So I have 9 times the square root of 2. So in order to be able to simplify your radicals, you have to understand how radicals work and what a square root is doing, right? So a square root is breaking down your number into the two factors. When they multiply together, give you that square root. or give you that number that's under the square root. So we know that 3 times 3 is equal to 9, right? So that means that the square root of 9 is 3. Why is that? Because the square root is looking for that one number when multiplied by itself gives you the number that is under the square root. So 3 times 3 is 9, right? So a square root is the opposite of a square. 3 squared is equal to 9. The square root of 9 is equal to 3. So the square root cancels out a square, right? It is its opposite, right? So everything in math has an opposite, right? Except for 0, because 0 is not something that is one thing or the other. But everything in math other than 0 has an opposite. So a negative has a positive as its opposite. Addition has subtraction. Division has multiplication, right? And so squares, when we're multiplying one thing by itself, so 3 times 3 is the same as 3 squared, right? The opposite of 3 squared, right, would be the square root of it. So the square root of 3 squared would just be 3, because the square and the square root cancel each other out. Okay? All right, so we're going to try another example. We're going to be doing something similar. All right, let's try 3 times the square root of 50. We're going to do it first is we're going to ignore the fact that that 3 is there. We know the 3 is there. We're going to leave it there. We're not going to forget about them, but we're just going to break down the 50. So using my list of perfect squares, right? I'm going to only use the list that's smaller, of course, than 50. Which one of these is the biggest one that goes into 50 evenly? There's a couple there are a couple things, a couple ones here that go into 50 evenly, that can be divided into 50 evenly, but 25 is the largest one, because 25 times 2 is what? 50. So I'm going to break this 50 down into the square root of 25 times the square root of 2, because 25 times 2 is 50. What is the square root of 25? Well, how do I make 25 when I want to, what are the factors of 25? What are the two factors of 25? Well, it's 5 and 5. So that means the square root of 25 is 5. So what do I have left? I have 3 times 5 times the square root of 2. So I have 3 times 5 times the square root of 2. So again, to simplify this, I need to multiply these two numbers together. What's 3 times 5? 3 times 5 is 15. So my answer here is 15 square root 2. Undo that circle. I don't want it to get in the way of you understanding that it's 15 square root 2 is my answer. Okay? So that's how we do that. That's how we simplify numbers under a square root. So let's think about this next step over here with number 3. We're going to simplify the number, and then we're going to simplify the variable. So I'm just going to separate the two for right now. I'm not even going to think about this variable. I'm going to pretend this variable isn't here. I might even just rewrite the whole thing. I'm just going to do the square root of 320 times the square root of x cubed. All right, I just want to ignore this for now. This is there, but I don't care about it. So I want to focus on the 320. Okay. So I gotta figure out a number that goes into 320 evenly. Well, you know what? I'm not gonna think about it as 320. I'm gonna think about it as 32. Which one of these numbers up here goes into 32 evenly? Obviously, it has to be a number smaller than 32. So let's start with 25, go 1 to 25. And of course, we can ignore 1 because 1 doesn't help us in any way. So which numbers between 4 and 25 go into 32 evenly? There's a couple of them, but the largest one is 16. So I know that 16 is going to go into 320 evenly because 16 goes into 32 evenly. 16 times 2 is 32. So I'm going to split this square root into the square root of 16 times the square root of 20. Because 16 times 2 is 32, 16 times 20 is going to be 320. All right, the square root of 16 is 4. But now I have to split 20 into its corresponding parts. So which perfect square up here goes into 20 evenly? The only perfect square that goes into 20 evenly is 4. So I have to split that into the square root of 4 and the square root of 5, because 4 times 5 is 20. What is the square root of 4? The square root of 4 is 2. So for my final answer, I have, well, not final answer, but part of my answer, but this, because I'm only doing right now the square root of 320, I have 4 times 2 times the square root of 5. What's 4 times 2? That's right, 4 times 2 is 8, so it's 8 times the square root of 5. That's my simplification so far, but I'm not done because I have to do the square root of x cubed. Okay, well, I can't simplify x cubed by very much because a cube is not an even number, and so all I can really do is leave it the way it is under the square root. So I'm just going to put it back under the square root next to the 5. So it's going to just be equal to 8 times 5x cubed. I'm just going to leave that the way it is. If this were an even number, I could reduce it some, but it's not an even number, so I just have to leave it like that. Okay. All right, and now my last one, I'm going to change my color because 4 might run into 3 a little bit, so I'm just going to change the color. So we're going to work with, we're going to leave this 3 alone. This 3 is going to stay where it is. And then we're just going to simplify the 324 by itself for right now. We're then going to simplify the x squared by itself. And then we're going to leave that y z to the 5th also by itself. Okay, so let's work on this 324. Okay, so what number is going to go into 324 evenly? I can't use 16 again this time, unfortunately, because it doesn't go into 324 evenly. It goes into 320 evenly, but not 324. So let's see, I can add some more numbers if we want me to. I can add the rest of these perfect squares in here that I don't have up yet. Does any of these, do you ever know if any of those go to 324 evenly? So maybe there might be a bigger number that goes into 324 evenly, but I know that 4 goes into 324 evenly because 4 goes into 32 and 4 goes into 4 evenly. So it's going to go into 324 evenly. So I'm going to split it into 4, the square root of 4, and the square root of 81. So yes, it does go in. So another number does go in evenly, right? How do I know it's 81? Because 4 goes into 32 8 times, 4 goes into 1 4 times. So 324 is actually another perfect square, but I don't know that off the top of my head. I wish I did, but I don't. The square root of 4 is 2, and the square root of 81 is 9. So what's 2 times 9? 2 times 9 is 18. So the square root of 324 is 18. So you don't have to memorize all of the square roots all the way up to anything. You can still just use the simplified method to figure it out. So 18 is the answer for this square root. Okay, and now we have the square root of x squared. Well, because 2 is an even number, I can do this, right? And then they cancel each other out, because I was saying, right, that the opposite of a square is a square root. So all I have left is x. But these can't be simplified because the y is an even number, as an odd number, excuse me, and the z has an odd number exponent as well. So I have to leave the rest of it under the radical. So when we simplify this answer, it's going to be 18x times the square root of yz, this is a z, to the 5th power. Let me write that again because it's not really straight. I want to make sure you guys see it straight on. 18x times the square root of y times z to the 5th power. Okay, so this is your